Hello, my name is Jazz. I'm going to talk about my big project for quarter 2 high school math 3. So in this video, as usual, I will talk to you about the high school math 3 big project for quarter 2 due on midnight of Sunday. So this is about inequalities and linear programming. This is the introduction and I will tell you what I have learned. So in quarter 2, I have studied the standard CED 124, create equations that describe numbers or relationships. So in this standard and in the quarter, I learned how to use quadratic functions in different ways to find what was given and asked, like height, time, and all that stuff. Then I am able to graph the equation into Desmos and find the results that I look for. And using the program, I can also see the time the object is at its highest height, lowest, or synchronized height with another object. So for example, a ball, gymnast, or pumpkin, and using the inequalities to define the variable. Next is REI 11. Represent and solve equations and inequalities graphically. So in this standard is about solving and interpreting equations and inequalities at the same time, also solve them using graphs. So the program I used was Desmos. And I interpreted by scattering the information in the ordered form and explaining which one is x, y, maximum z, and its variables. Then I graphed the equations that I have obtained from Desmos and then find the optimal solution. To prove if the optimal solution was correct, I used a program called Lingo. And so this standard is IF 426. Interpret functions that arise in applications in terms of context. So in this standard is about turning quadratic functions into perfect squares, solving them, and completing the squares and factoring them. Using the information given, we are to use this equation to represent what the question wants to find based on the variable in vertex form. And in the same standard, we also had to find the time. For example, how much time a man needs to shoot the ball while it is in the air. And so I have learned it, at the same time define its domain and range using inequality signs, like what I said in the first standard. And I have found how to find the constant rate by using the equation for slope, y2 minus y1 divided by x2 minus x1, and putting the answers into this equation, b minus 4ac, to find the answer. And in this last standard, analyze functions using different representations. These last standards are about graphing trigonometric functions that model after a graph. For example, temperature and of a certain place. Like I did in my big project, we did about like places that have two different temperature and we choose one and stuff, and finding the amplitude, period, phase shift, and vertical shift using the equations learned. In this very standard, I also got to relive the lessons about exponential decay and growth using this equation that can be used for the negative and positive. And most decays are used for chemicals that slowly disappear after time passes by, and the growth is used for growing populations of living things and even money when you put the money in the banks. And lastly, finding the weight of a certain matter after a certain amount of years using the function given. So here is big project number 1. The height of a gymnast's bounce above a trampoline is a function of time after the takeoff bounce. So this one is about finding the height and the time using this function rule over here. And in this one, I have graphed it in Desmos. You can find the time and height over here. And this is like a boundary so that you can know that like the gymnast won't get out, like the gymnast won't escape from this boundary. And so in this question, when will the gymnast be at least 8 feet above the trampoline? So I have put this into the equation and I found out that these are the times. Next are the similar questions. How long will the gymnast be in the air during the bounce? So I have found that this is when the gymnast falls to the ground after jumping up, and the gymnast will be about 1.607. The time is unknown in the air before reaching the ground. And to add up, Mr. Freddy, you have added another gymnast on the trampoline. And this question, for what values of t the two gymnasts are at the same height? To find out, I have also graphed it, and I have found out here. At the height of 10, the two gymnasts will be at the same height. So this is the synchronized jumping part I have talked about. And these are the inequalities. Big project 2 was about like arranging the information given into ordered forms. For example, this is about a farmer wants to plant white and yellow maize on his 50 hectares of land. And these kind of questions will give out a mixed variety of like prices or amounts of stuff in the same category, and we can all put it into a graph like this, which shows the intersection. And here's the optimal solution I have obtained from using Desmos's graph. And here is what a lingo looks like. This is wrong because the information I have inputted wrong, but this is an example of how it will show up. This should be about 30,000, but my calculations were kind of wrong. In Big Project 3 is about also finding the height and like the time also, but using a different kind of equation. So this is about Mr. Freddy and Mr. David going to a hunting trip, but once they got there, they realized the hunting that is very cruel and decided to do other shooting activities. So one of them threw a small ball and the other had to shoot. So with the information given, I have made a function that represents the height of the ball based on the time in vertex form. And here is also another question about time, how much Mr. David had until he had to shoot the ball in the air. And here are questions about domain and range. Domain and range is mostly about like the time from the least to the greatest, and the height to the least to the greatest can't be more than this much or that much. And this is about the constant rate using the equation for slope and then putting it into b minus 4 times a times c, but this was wrong. Yes. And this one is Big Project 4 that I have failed, and this one is the one I have written it again using this graph about the temperature in a certain place during each month. I have made a trigonometric function that models the average low temperature in the city. Trigonometric functions can vary in shapes, but then I have decided to use this scatter plot, and this is the trigonometric function. This is the equation. Using this equation, I can find the amplitude, period, and phase shift, also vertical shift. And here is about money, exponential growth. This is about exponential growth too, but with living things, graphing out the function. And this is about exponential decay. I have made up this radioactive substance, boom boom, and gave it a function, and finding the weight after 100 years and 600 years. This is my reflection. So, okay. In my reflection, I had to list at least 3 skills I have learned from this project and explain them in details and provide examples of application of skills. So, in this standard, I have learned how to solve equations, quadratic, and use them on graphs and describe equations using inequalities. So using this quadratic equation, ax to the power of 2 plus bx plus c, I can use it on the same as the gymnast, where a ball is up in the air and we can answer the questions. And this question, to find when the ball hits the ground, you have to arrange the given information by using this example. A juggling pin is thrown up straightly 5 meters above ground with a velocity of 20 miles per hour. And so with the gravity pulling it down, it will be faster, so the time will lower to 8 miles per second. Should be per hour, but yeah. This standard is like most likely to be quite the same, so I put them together, and using this same project like from above, I had to put them in ordered forms. So maximum z equals to 600x plus 900y is the income of the yellow and white maze. And for man hour, I put it in this format. 30x plus 20y must be lesser or equal than 1000 because it is the man hour on the yellow and white maze. That must be less than or exactly equal to 100 man hours because they only have 100 man hours. And this is for the fertilizer. The equation for the yellow and white maze in tons, as it has 120 tons of fertilizers, so it cannot be more or equal than 120. Same with this optimal solution. You can check it in Lingo. Next is rewrite quadratics into perfect squares, solve by completing squares and factoring. So in this, I had to use this equation, a times x minus h to the power of 2 plus k. X for this question is the starting height, h is the time after thrown in the air, and k is the maximum height the ball has reached. Using this equation, I can find out how many things asked, such as height after thrown and time when reached to the ground, and also the time at maximum height. And in this same standard, I use this hunting trip question. Just as I said from above, these are the examples how to do it. I applied it to the standards. This one is, how much time did Mr. David have to shoot the ball in the air? You have to use the function and make it equal to 0 and move the numbers around so that x can be alone because we don't know what x is and we're trying to find what x is. Next is analyze functions using different representations. I have learned how to use sine, find amplitude, period, vertical shift, and phase shift, and how to solve exponential decay and exponential growth. I can graph the information listed in GeoGebra and show it in the trigonometric function belonging to the information. Then use the information to determine the amplitude, period, phase shift, and vertical shift. Y equals to a cos times bx minus c plus d is the equation I can use upon finding the amplitude, period, phase shift, and vertical shift. A in the equation is amplitude. By finding the amplitude, we have to take the maximum of the graph minus the minimum of the graph divided by 2. B is the period, is 2 pi divided by b, or 2 pi over b. C is the phase shift, negative c divided by b. D is the vertical shift, maximum of the graph, maximum number in the graph, and minus it with a. Yes, and then you will use this trigonometric function and solve it, which will be looking like this. And I have learned about the exponential decay and growth using the same formula as each other. If it's exponential growth, you use positive or plus, and if it's decay, use negative. P0 is the starting number, R is the rate of change, and T is the time given. This one is the growth about a highly reproductive amoeba, which he starts at 30 amoebas and observes them double every 5 hours. So I put the numbers into the equation that I just showed you, and I can find out how long it would take amoeba to grow to 1,000 amoebas. And boom, it would take 0.81 hours. And this is decay. The weight of a newly found radioactive substance, boom boom, remaining after T years and given with the given equation of the weight equals to 2,000 times 4 to the power of negative 0.03 times T. And I will then show you the more you put numbers in the place of T here, the more the weight will go down due to the negative sign, and due to the fact that it's a radioactive substance that fades away after time passes by. So this is the weight after 100 years, as you can see 72.2. And if you can see the weight after 600 years, it lowers down to 28.8. These are the reference of the website I used. Math is Fun, GeoGebra, Classroom, Google, Desmos, and Shmoop. So thank you for watching, and I hope you enjoyed.